Do you like my game? It took a few months to build, and I'm earning some revenue by showing some ads between levels and providing in-game purchases for power-ups for those trickier levels. But wait, I noticed that when I'm showing too many ads, my players tend to not buy as many power-ups in my game store. But when I reduce the number of ads, my in-app purchases go up by a little, but not by much, and my ad revenue drops off. Egg ads. How can I balance my in-game purchases and ads to optimize my app revenue between all my different kinds of players? I'll need the power of the framework to help me out. Okay, as you may have figured out, this episode in the series will focus on hybrid monetization and how to balance your in-app purchase revenue with your ad revenue. Hybrid, what you say? Okay, let me take a step back and explain what we mean about hybrid monetization. So far in this series, we've been focused on apps and games that generate revenue solely by showing ads and covered different ways to optimize your app ad revenue. Well, as apps and games get more complex and the level of player skill and user engagement go up, you might also have in-app purchases as part of your app experience. In that case, you have two revenue streams, one for in-app purchase and one for ads, hence the term hybrid monetization. There are also other monetization models out there as the level of skill and engagement go even higher, like strictly in-game purchases for RPG and strategy games, or subscription-based monetization for PC and console online games or news apps, but we won't cover those today and focus in on hybrid monetization. So what makes balancing different revenue streams in hybrid monetization so tricky? Besides the term hybrid sounding like some kind of gas and electric powered monetization model. Well, let's go back to my Space Invader style game. Now, as I mentioned before, my game has power-ups that are available for purchase to get through some of those tougher levels. This is how I'm earning some revenue through in-app purchases. But I also want to earn some revenue by showing ads. And one common way to incentivize players to watch some ads is by offering them a reward, like in-game currency they can use to buy power-ups by using AdMob rewarded ads. But if I'm offering rewarded in-game currency to buy power-ups, and I'm also relying on in-app purchases for power-ups to earn revenue, won't one potentially cannibalize the other? How can I balance both to maximize the total revenue my app can generate across both experiences? The problem can also be a lot simpler than that too. Showing too many ads can hurt my user engagement, and less engagement means less players making purchases, less players viewing ads, so less revenue overall. It's a tough problem to solve. Naively, you might think, okay, I'll create user segments for my purchasers and non-purchasers and only target ads to my non-purchasers and not to my purchasers. That might sound like a good idea, but it has a few drawbacks. For one, non-purchasers may become purchasers one day, and offering an experience that allows them to become purchasers can be important. For two, there are different levels of purchasers, including the top 5%, occasional purchasers, or those who only make a purchase that one time. It seems like a bad idea to turn off ads completely for players who only purchase an item once. And third, turning off ads for all purchasers seems like a bad idea in general. This feels true for some of the same reasons as point number 2, but also because rewarded ads can complement a purchasing player's experience too, and they may actually want them. So yeah, using a rule of absolutes isn't the best way forward. Now what if instead of rigidly defining players as purchasers and non-purchasers, we could predict which players were going to make a purchase? Well, thanks to a new feature in Google Analytics, now available in Firebase called Predictive Audiences, we can do just that. Using Predictive Audiences, we can create different user groups based on their probability to make a purchase, and adjust both the ad and in-app purchase experience for each group. Let's take a look at how we'll use Predictive Audiences to help balance our two revenue streams as we design our experiment. Okay, so let's talk about how we can use predictive audiences to set up our experiment. So referring back to the framework, if we use Google Analytics to create different predictive audiences, we can then use Firebase Remote Config and A/B testing to adjust and test different ad and purchase experiences for each of these user groups, catering them to what works best for each group. Now, if you'd like to get more familiar with setting up the framework for your app, check out the first episode in the series that covers in detail how everything connects together and how to configure each piece for your Firebase project and app SDKs. Getting back to predictive audiences, one neat thing about them is that they're configurable, which means we can create different predictive audiences for different events and segment the audiences based on the probability for members to take the predicted action. So for example, I can create a predictive audience for, say, the top 5% of my players predicted to make an in-app purchase, and another audience for the bottom 5%. When it comes to what you do with the predictive audiences, there are tons of possibilities. For example, you could target the top 30% of predicted purchasers and direct them to only an in-app purchase experience without ads. And for the lower 70% of users, show ads mixed in with paths to the in-app purchase experience. Or maybe you could instead target the top 5% of users and don't show ads to them, as well as create a bottom 20% who see ads at a normal rate, and a middle 20th to 95th percentile group who see ads at variable frequencies. For this episode, we're going to go with that second scenario. So for my top 5% group, I won't show any ads. For the bottom 20%, I'll show ads at a default higher frequency, as well as direct them to the store. And for my middle 20th to 95th percentile group, show ads, but at a lower frequency than my bottom 20%. But how many ads should I show them? Well, perhaps A/B testing different ad frequencies among this group is the way to figure that out. By the way, does that topic sound familiar? Well, that's because it's the exact same topic we covered in Optimize Your App Revenue episode number 2. In today's episode, I'll cover the steps for setting up A/B testing ad frequencies for this middle group, but if you want a more generalized and in-depth look at A/B testing for ad frequency, check out the link in the description for episode number 2 on that topic. Okay, getting back to how we'll handle the last middle group, let's set up the following A/B test. So for users in the 20th to 95th percentile group, let's try experimenting with different ad frequencies with the goal of optimizing our total revenue. That is both in-app purchase revenue and ad revenue. At the end of our different setups and A/B tests for each of our different groups, we can compare the total combined revenue for both ad and in-app purchases for each group and see how they're performing. We'll get into specifics on doing this when we reach the Analyzing the Results section in this episode. For now that we've designed the setups we'll use to start trying to balance our revenue streams, we can move on to implementing them in our app. Okay, so to implement our solution to balancing our in-app purchase and ad revenue, we're going to use the power of the framework. That is, we're going to use Google Analytics to create our predictive audiences and measure the results of our experiments and user audience experiences, and use remote config and A/B testing to target and deploy our different ad experiences and testing variants. So let's start with the first step and create our predictive audiences, which we can do in both the Google Analytics console or the Google Analytics section in the Firebase console. So here I am in the Firebase console, and I'll scroll down to the Google Analytics section and click on Audiences, and then the New Audience button. Once opened, you'll notice there's a new section here for predictive audiences that I can select. So there are a few suggested audiences we can use here, like likely 7-day purchasers, predicted 28-day top spenders, likely first-time 7-day purchasers, and a few more. Now, as predictive audiences is a fairly new feature, some of these might not be ready to use just yet, as there is some backfilling of data that needs to occur. We could use these, but we could also get more specific by creating a custom predictive audience. So let's do that. So I'll click on Create a Custom Audience, and for the condition, I'll scroll down to the Predictive Metrics section and select In-App Purchase Probability. I'll name this audience Bottom 20% Predicted Purchasers, and then click on Add Filter to further configure this audience. So first up is the user range for the prediction, which in this case is the bottom 20%, so I'll select the custom range here and specify the 0 to 20th percentile for this group. For the prediction time window, 28 days sounds good to me, so I'll use that setting here and then click on Apply. As the audience gets created, I'm also shown how many users are included in the new group I just created, which is certainly useful info as I can go on to create more predictive audiences. Now I'll hit save and go on to create my second audience, the ones between the 20th and 95th percentile predicted to make a purchase. So I'll create another new audience in the same way, select Create a Custom Audience, and name this one Middle 20th to 95th percentile Predicted Purchasers. I'll select the in-app purchase probability predictive metric and select a custom range from 20 to 95 here. Then I'll click on Apply and Save. And finally, I'll create the final predictive audience, the top 5% of users predicted to make a purchase, and I'll create a custom audience one more time, name this one Top 5 Predicted Purchasers, select the in-app purchase probability predictive metric once more, and set a custom range from 95 to 100. Then I'll click on Apply and Save. Okay, now that I've created my predictive audience groups, I'm ready to start customizing the experience to start balancing my in-app purchase and ad revenue streams between them. As a reminder, for the top 5% of predicted purchasers, we won't show any ads and focus on the in-app purchase experience. For the middle 20th to 95th percentile group, we're going to try A/B testing different ad frequencies. And for the bottom 20%, I'll just show ads at a standard frequency. At the end of it all, we'll analyze the results to compare and see if our configuration improved our bottom line or if we need to make more adjustments. Now to configure these tests and custom setups among our user audiences, we're going to use Remote Config. As another quick reminder about Remote Config, RC allows you to create key value pairs in the cloud that you can push out to your end users' app instances with different sets of values based on different specified conditions. In this case, we're going to use Remote Config to control the ads we show or don't show to our different user groups, as well as to deploy our A/B testing variants. But what Remote Config parameters should we actually create for the setup we're planning to use today? Well, there are a few options. Since we're technically creating two different setups, one that controls whether we show ads or not entirely, and another to A/B test different ad frequencies, we could create two separate sets of parameters for both configurations. This would have the advantage of each setup also being handled individually in code, so I could have two exclusive code paths controlling the app experience for both setups. Another option is to reuse the same parameters across all setups, which simplifies the process but could complicate how it's handled in code. We'll go with this one in this episode since, as you'll see, it doesn't complicate the code by much and in fact makes the configuration easier. When you set up your own experiments, consider both alternatives to suit your conditions best. So we'll have one parameter here called Show Ads, which determines whether or not an ad should be shown. I'll use that to control whether I show ads or not for my top 5 and bottom 20% user groups predicted to spend. I'll also need a second parameter called Ad Unit ID, representing the AdMob ad unit that I'll use to show ads in my app. This will be the same for my top 5 and bottom 20% groups, but different for the various A/B testing ad frequency variants I'll use for the middle 20th to 95th percentile groups. As a reminder, AdMob ad unit can be configured in the AdMob console to show ads at different frequencies. Episode number 2 covers that in a lot more detail if you'd like to get deeper into that. As a quick recap, I might have a default ad unit ID configured to my default ad frequency, say 6 times every 30 minutes. I'll then create a few more AdMob ad units represented with unique ad unit IDs and configured to different ad frequencies, like say 1 time every 30 minutes, 3 times every 30 minutes, and finally 4 times every 30 minutes. Once again, if you want to learn the full details about setting up an ad frequency experiment from start to finish, check out episode number 2, which covers just that, in addition to creating the different ad variants in the AdMob console. For now, let's go ahead and start configuring some of these RC parameters in the Firebase console. Okay, so I'm back in the Firebase console, and I'll scroll down to the Remote Config section and click on Add Parameter. For the name of the parameter, I'll use Show Ads, and by default, its value will be true. Now I'll add some conditional values for our different user audiences. So I'll click on Add Value for Condition, and then Define New Condition. Let me start with the condition for the top 5% predicted purchasers. So I'll name the condition Top 5% Predicted Purchasers, and it'll apply for any users in the predictive audience I created earlier for my top 5%. Then I'll click on Create Condition and set the Show Ads value for this audience to false. Now technically, I don't necessarily need to create another conditional value for the bottom 20%, since the default is already true. But I'll add it anyways for good measure, and in case I ever want to change the value for that audience in the future. So I'll click on Add Value for Condition and Define New Condition once more, name the condition Bottom 20% Predicted Purchasers, and then click on Create Condition. the value I'll use for this audience is false. Then I'll click on Add Parameter. Now I need to create the Add Unit ID parameter. So I'll click the Add Parameter button one more time and name this parameter Add Unit ID. The default value for this one will be the standard default add I've previously configured in the AdMob console. The value won't change for different conditions here, only for the different variants in my A/B test. So I can just leave it at that for now and click on Add Parameter. Now I'll publish changes, and I'm ready to configure the final setup for my middle group of 20th to 95th percentilers. Is that a word? Anyway, to start creating the ad frequency tests for my middle group, I'll click on the overflow menu on the Add Unit ID parameter right here and select A/B test to, well, configure my A/B test. First, I'll start with the name of the test. I'll call it Ad Frequency Experiment for Middle Predicted Purchasers. And in that description, I'll add in that this is a test for different ad frequencies for the 20th to 95th percentile group of predicted purchasers. Next is the targeting for this experiment. First, I need to choose the app, which in this case will be my Android app. Note that because experiments are configured per app, if I wanted to create the same experiment for my iOS users, I'll need to duplicate this experiment and target my iOS app instead. Next, I'll add an additional targeting option to configure this test to only be exposed to users in the middle 20th to 95th percentile predicted purchasers audience by selecting the user audiences here and the middle group audience from the list right here. For exposure, I'll actually set this to 100% because I want to ensure that I have enough users for A/B testing to collect sufficient data to make some conclusions, and also because in this case, I'm already segmenting this experiment to a specific audience, and there's no major impact to exposing that full audience to this test. Next, I'll select the goal that A/B testing should track to determine which variant is the leader. And in this case, that will be the estimated total revenue, since that combines both my in-app purchase revenue and the ad revenue that I'm seeking to balance. There are also some important secondary metrics to track, such as user retention, which is already added on, and crash-free users, which is always a good idea to include. Since the predictive audience groups are predicting the probability of a purchase over a 28-day period, maybe I can also include a longer-term user retention metric here. But that's totally optional, and you can add in whatever makes sense for your own test case. And now to configure our different variants. So I already have the Add Unit ID parameter here, but I'm also going to add the Show Ads parameter to each variant too. Although for this A/B test, the value for that parameter will be true for all variants, it'll make the implementation for both setups a bit easier a little later when we get to coding these parameters into our application. So for the baseline, I'll use the same Add Unit ID value as the default, which shows ads 6 times every 30 minutes. Next, for variant A, I'll choose the Add Unit ID value for the pre-configured AdMob ad unit that shows 1 ad every 30 minutes. And for variant B, I'll use the Add Unit ID for the ad unit that shows 3 ads every 30 minutes. And finally, for variant C, I'll use the Add Unit ID for the ad unit that shows 4 ads every 30 minutes. Next, I'll hit review, and I'm ready to start the experiment. But before I do, I now need to write the code to implement and use these remote config parameters in my application. Let's do that right now. First, I'll need to initialize remote config and to configure it to fetch the parameters we just created. So for Android, this would look like this. First, we get the remote config instance, then use the remote config settings builder to build and configure our settings and then set them. For the minimum fetch interval, which is how often remote config should invalidate its local cache and check for new values, I'm using 12 hours as a time interval. I could probably make it longer since I'm expecting to keep the values for show ads and the A/B testing variants constant for a longer evaluation period, but 12 hours seems like a sensible fetch rate. Next, I'll need to make the call to fetch the remote config parameters from the RC servers and activate them for use in my app. So we've got the fetch and activate call here, and then we add a completion listener which checks that we were successfully able to fetch and update the remote config parameters. If we were, we can get both the show ads and the Add Unit ID values for this app instance. Now I'm ready to figure out which ad experience I'm going to load for this user. First, I'll check if I should show ads at all. This will be false for my top 5% users, but true for my bottom 20% and middle 20th to 95th percentile users. If it is true, then I'll make the call to load the ad unit, passing in the ad unit ID. This will be the ad unit ID with the default frequency for my bottom 20% user group, and for the control group from my middle 20th to 95th percentile users. Others in that group will get one of the 3 less frequent variants I configured. Now let's see what this looks like for iOS. So again, we first retrieve the remote config instance, then create our remote config settings object to set the minimum fetch interval, and finally set the whole RC settings object back to our remote config instance. Once again, using a fetch rate of once every 12 hours is sensible for this experiment. Next, we'll need to fetch and activate the remote config parameter values. So first, we'll make the fetch call, and if the call succeeds, make the follow-up call to activate the fetched remote config parameter values in our app. If that all goes well, we can now check the value of the show ads parameter, and if it's true, load the correct ad using the ad unit ID for this app instance. For the Unity SDK, the setup looks quite similar too. So you'll get a remote config instance and create a config settings object in a similar way, and set the minimum fetch interval through a ulong, representing the total time in milliseconds. I'm using a time span here to make that a bit more readable and setting the interval to 12 hours. Then we just make the call to set the config settings object, which is an async operation in Unity. So we're adding a continue with onMade thread callback here to verify that setting the config was successful. And now we can make the call to fetch and activate the remote config parameter values. So that's as simple as just making the call, adding a continuation to handle the result, and seeing if it was successful. After fetching the remote config parameter value, we can check if show ads is true for this user's app instance, and if so, load up the correct ad and show it. Okay, with this all wired up and ready to go, we're now ready to start the experiment and deploy our remote config parameters and conditional values so that our bottom 20% see ads at a default rate, our top 5% don't see any ads, and the middle 20th to 95th percentile users receive one of the A/B testing variants. For good measure though, it's always a good idea to test the implementation before deploying it. You can do that by updating or adding new conditional values to toggle the show ads value and setting the ad unit ID parameter in the console, and setting the minimum fetch interval to 0 seconds during development and testing time. With that done, we're ready to roll out these configurations, wait a little while to generate some result data, and finally analyze the results. All right, we made it. We're ready to analyze the results. But what should we analyze? Well, let's consider what a good measurement metric would be here across our different user segments. If we think about it, one metric that makes a lot of sense is ARPU, or average revenue per user. For one, it combines both ad revenue and in-app purchase revenue, and secondly, it's a good way to make direct comparisons between revenue performance for the different groups. Let's start with looking at the ARPU for the bottom 20% and top 5% user groups. So if I go into the Google Analytics reports section, there's a handy monetization report I can view that provides a look into the ARPU our game or app is generating. This will be under the games reporting section if you're developing a game, or under the life cycle section if you're developing an app. There's a ton of really useful information here, but for now I'm just going to look at the ARPU, which I can see right here. Next, I want to see what this looks like for the bottom 20% of users and the top 5% so I can compare them. So I'll scroll up here and click on Add Comparison. Here, I'll select the audiences we created earlier for both of these user groups, first selecting the bottom 20%, and then selecting the top 5% user audiences. Then if I scroll back down to the ARPU report I was looking at earlier, I can see that the bottom 20% are almost matching the global ARPU, which is probably what I expected, since the vast majority of my users are less likely to make a purchase and probably live in this group. For the top 5%, the ARPU is significantly higher than the global average, which also matches what I suspected, since this group is very likely to make a purchase, and purchases are much more valuable than the ad revenue generated per user globally. Now for the really interesting part, the middle 20th to 95th percentile group, who have been both receiving ads and hopefully making purchases, and for whom I tested different ad frequencies. To see those results, I'll go back to the Firebase console and open up my completed experiment to check out how ARPU compares in my A/B testing group. Looking at the results here, I can see that variant B, that is the one that shows 3 ads every 30 minutes, is outperforming all other options. This means that when it comes to showing ads to my middle group users, it seems like the middle frequency is the sweet spot, where I'm generating more revenue than the lower frequency and highest frequency variants. The ARPU for variant B is still lower than that of my top 5% group, but that's kind of expected since this group is less likely to make purchases, which can heavily skew average revenue towards the higher end of my top 5%. Now, what we do with these results will depend on how you want to move forward and what makes the most sense for your app. After seeing the fairly large variance between these variants, that's a nice tongue twister, I might want to drill further into seeing how the revenue generating behavior differs in further segmented predicted groups. Maybe a 20th to 40th percentile group, and 40th to 80th percentile group, and an 80th to 95th percentile, and run the same A/B tests for each of these to see if there are better local optimums for each group. Or I can just decide that for now, I'll go with variant B for my middle group and roll it out to all users in my middle 20th to 95th percentile group by clicking on the Rollout Variant button in the Firebase console. After seeing that the slightly lower ad frequency worked better for this group and generated an even higher ARPU than for my bottom 20%, I might also decide that I want to try that ad frequency for the bottom 20% and see if there's any uplift, which thanks to my already wired up code, I can do just by creating a new conditional value for the ad unit ID for my bottom 20% users with the lower frequency ad unit. There are plenty of possibilities, and the decision is really up to you and what you want to try next. The cool thing is that with the remote config implementation already in place, you can keep making adjustments or entirely new experiments for these predicted purchasing users. And with the conclusive evidence returned in reports and A/B testing results, keep making the tweaks you need to balance and optimize your in-app purchase revenue and your ad revenue. You could say that Firebase takes the balancing act out of balancing your in-app purchase and ad revenue. And that's it for this episode. It was quite a long one, and probably one of our more complex topics so far in this series. But it's also one of the most important and popular topics when it comes to developers figuring out how to optimize revenue between all their different revenue sources. By the way, when we were doing our A/B testing on ad frequencies, you might have thought, hey, what if some people like more ads and some people like less ads, even in the same group? Well, that's where personalization comes in, where you can personalize the ad frequency to each group specifically to help balance revenue in a hybrid monetization in a different way. Stay tuned for a future episode on that topic. So what do you think? Inspired to try out the setup we looked at today? Have more scenarios you would like to learn more about when trying to balance your in-app purchase and ad revenue? Well, let us know in the comments. And as always, please do like, subscribe, or share this video to let us know you'd like to see more ways to optimize your app revenue. Until then, see you in the next episode. Take care and goodbye.